What's happening, dogs? Mr. Allen here, drawing some angles in standard position in this video. For this one, we're working with degrees. I'm going to make another video dealing with radians, so make sure you check out that one as well, because they usually ask you to do both, especially if you're in a pre-calc class. So the first one here, I got 250 degrees. I think it's helpful at first to label out our axes here. We got 0 degrees, then we have 90 degrees. Let me put little degrees there. Then we have 180 degrees. 270 degrees, and then all the way around to 360 degrees. All right, that way we can kind of position things accordingly, and eventually you'll just get so used to these axes where the degrees are and all that stuff that you won't even have to write them down. But to start, I think it's helpful. So for 250 degrees, if it's positive, we start by rotating upwards. We're going to go past 90, past 180. Are we going to get all the way to 270? No, we're going to be a little shy of 270. I'll say right about here. Usually you'll put a little arrow, and then boom. That is our angle in standard position. Cool? You can even label it 250 degrees. That's about all they're looking for, right? Usually, it's nice to be either a little more than halfway or a little less than halfway to show that you kind of know which one it's closer to. That's always nice, but as long as you're in the right quadrant, in the rough right spot, definitely got to be in the right quadrant, but roughly the right spot, you're probably going to get full credit for it. This one, I'd give full credit, 100%. Whoever did this, stellar student. All right, next one. Let's see here. Negative 410 degrees. Well, if it's negative, I'm gonna write out the degrees again on this one because we're going negative. When we're going negative, we still start out with 0, but then we're gonna have to go down as we rotate. So negative 90 going down, then negative 180. So the 180s are the same. Then negative 270 is up here, and then this is negative 360 degrees. Okay. So we start by rotating downwards. Well, we're going to go at least one full revolution here. That's negative 360. And then if I add 90 to negative, or sorry, keep subtracting, I guess, if you will. But 90 plus 360 is going to be 450. So this would be negative 450. So really I only need to go like another, negative 50 degrees. So we're going to be kind of the same idea as last time, but mirrored, if you will. And now I'm going to be in quadrant 4. So sometimes you'll put an arrow there. Sometimes I've seen people put arrows on both. I've seen them just kind of end it here and then put an arrow here. Ask your teacher what they want. But this would be negative 410 degrees. Because again, this would have been negative 450. So we're a bit back from that. Sometimes they'll even ask, name the quadrant. So this would be quadrant 4. So that's, boom, 4. This would have been quadrant 3, 1, 2, 3. All right. For those of you that don't remember Roman numerals or whatever, it's 1 before 5. That's why that's 4. If you put the 1 after the 5, it's 1 after 5. Fun fact, in case you didn't know about cool Roman numerals. It's not a convenient numbering system, but we use it for Super Bowls. And so it lives on, right? Anywho, next one, 1200. 1200 degrees. Woo! All right, so now we got to do a little bit of counting here, right? And I like to draw little circles here. I think it's helpful. So I'm going to start in the center here, pretty close. We got 360, 720. Uh-oh, I'm losing the marker. Then 1080. Thank you, Sean White, okay, for helping me out with that, right? The rotations. Dude was spinning like crazy in that half pipe. Okay, so now, if I remember correctly, then another half rotation was 1260. Thank you, Sean White. So we're going to be, it looks like somewhere over in this vicinity, okay? So I'm going to get a better marker here because this one's dying on me. We're going to be something like this. Boom. 1200. Not 1260. I did my brain now. 1200, right? So if I was at 1080 here and I add 90, that's 1170 plus another 30. So right around there, I think if you were somewhere right in the middle, cool. Really, it should have been maybe more like up this way now that I think about that a little more. This may have been a little more accurate here for the 1200, a little closer to this axis than the center. So let's say that. Okay, I like that a little better, right? I would have erased it, if I was on a math test because I'd be using pencil, little Dixon Ticonderoga action. But there we go. Lovely. Okay, 1200. Next one here. That looks better. Negative 650. So I'm rotating downwards first. This is going to be negative 360. All the way around again is negative 720. So we're not going to go quite that far. Let's see here. So this would be negative 540 to here, right? And then if I add another 90, that's negative, so negative 5 And I think about these as positive numbers, like 540 plus 90, and then just throw the negative in front. 540 plus 90 is 630. Okay, so 630 here. And then I need to go like, what, another 20 degrees? And there we go. So that's negative 650. Cool. Awesome. Lovely. All right, so when you're doing a negative angle of rotation, you start by going down, okay? And then I just start thinking about positive numbers, and then I'll write it down negative, okay? So when you're backtracking like that with negatives, it can be kind of hard to be like, negative 360, minus 90, minus, it's like, wait, what? Hold on, negatives, right? And this is going to be non-calculator, okay? This is definitely going to be non-calculator here for putting these angles in standard position. So deal with them as positive numbers, but you're rotating by going down first. All right, there you go, guys. Drawn angles in standard form. I didn't list my quadrants here, not that I asked for it. This is 2, and this is 1. Lovely, because sometimes they'll ask that too, what quadrant will this fall in? And now you're prepared for both. Okay, guys. Thanks for watching. Have a wonderful day. If you have any other questions, let me know. And if you need that radians video, I'll put that one next in this playlist here, so stay tuned, because it's going to be a rad, get it? Rad time, radians. All right, I'm out.